All right, let's talk about our first major type of bonding. These are ionic bonds. So first, let's go ahead and talk about what an ionic bond is. Ionic bonds occur due to, and here's your key word, electrostatic attraction between, here's your other keywords, cations and anions. And another key word here, the electrons will be transferred. Sometimes in your middle school classes they call them stolen. Either way you want to look at it, transferred is the word you're going to see, or sometimes you can use exchanged. Either way, electrons were on one thing, now they're on another. One has all of them, then it has 0 of them. One needs one, takes one. So that's what's going on here. There's no sharing that's going to be covalent. But so transferred, stolen, exchanged, all good words. You'll find synonyms for those as well. So 2 key words that you need to know, because they're going to follow you for the rest of the year. And if you can't tell me what a cation and anion is after this unit, you're going to be in trouble and will probably fail second semester. Just being honest with you. So what elements are going to be cations? These elements are going to be metals. And a cation, by definition, is a positive charge. Remember, any time anything is charged, we call those ions. All right, so metals, remember that's everything to the left of the stair step, are going to be positively charged, and therefore will be considered cations. And then just for more information regarding cations, these will give up electrons, or you could say they lose the electrons. But either way, with the octet rule, it is easier for them to lose electrons than it is to get to a full outer shell, or than it is to receive electrons. All right, so 8 electrons is stable, or 0 electrons is stable. Think of it like that. It's easier to lose 1, 2, or 3 electrons than it is to gain 7, 6, or 5 electrons. We'll play around more than that. So anions are going to be opposite of the cations. So anions, since metals are cations, nonmetals are anions. If cations are positively charged, anions are negatively charged. If cations give up or lose their electrons, anions will gain or pick up electrons. So that's simple. An easy way to remember this is if you spell out cation, it has a T in it, which looks like a positive sign because they're positively charged. So once again, it's another one of those things where if you memorize what a cation is, anions are everything else. So or if you just want to go ahead and memorize them all, go ahead. But you've got to know for the rest of the year what a cation is and what an anion is, because it's going to be a big, big deal. So ways or types of bonds ionic bonds can be. Basically anything within metal or those polyatomics that we've been kind of looking at. You're going to get a little crash course in them when you get into class. If it has a metal or polyatomic, it is going to be ionic. So this can be between a metal and a nonmetal, such as sodium, which is a metal, and chlorine, which is a nonmetal. It can be between a metal and a polyatomic. So that would be like a calcium and a sulfate. There's cation, cation, anion, anion. It can be between a polyatomic and a nonmetal. So that would be like an ammonium as your cation, and then we already used chlorine. So we'll go with oxygen as your nonmetal. or it can be between two polyatomics. Once again, that could be like an ammonium and a nitrate. So you can see how this is going to work. Cations, they're positively charged, or metals and your polyatomics are listed first in the formula. Anions are going to be listed second. So properties of ionic compounds. Okay, these are called salts, first of all. Any ionic compound is considered a salt. So your table salt that you use is sodium chloride. Ionic bond, it is a salt, but that's not the only kind. There's almost unlimited possibilities of them. These have high melting and high boiling points. That should make sense. You put salt in your little saucepan when you're cooking, it's not going to melt or boil easily. Normally it just ends up burning to your pan and causing problems. These are soluble to some extent. Most of these are easily soluble. For instance, go back to your table salt. It dissolves pretty easily in water. Other ones with heavier metals, they are soluble normally to some extent. We'll get to that more in a later unit. So examples of ionic compounds include, you can see it up there, sodium chloride, calcium sulfate, ammonium oxide, and ammonium nitrate. Ooh, I did that charge. Also, if you see this parenthesis right here, if you're looking at that, you know you've got an ionic compound. So now let's draw some Lewis dot structures. We talked about them last unit, but now we're going to get into more specific kinds, ionic and covalent. So when you're doing an ionic Lewis dot structure, the overall charge of the compound must be 0. So the charges have to cancel out somehow. So cations wind up with positive charge and no dots inside of a bracket. I'll show you what that looks like in a bit. Anions end up with negative charges and 8 dots with the bracket every time. Don't make it complicated. The left side, the metal or the polyatomic, is going to have 0 dots. The right side, the negative charge, is going to have 8 dots. Always, every time. So let's go and look at some practice. Examples. Draw Lewis dot structures. I'm going to show you before what you did last unit and show you how they work. So this might take a little bit of time. So sodium and chlorine. So sodium is in A. It's in group 1, so it's a +1. Or has 1 dot, sorry. Chlorine is Cl, group 17. So we know that's got 7 dots. Now remember, they want to have 8 valence electrons or 0. Sodium is your metal, so it's going to give up. Chlorine is your non-metal, so it's going to pick up. And so now you end up with sodium with no dots, and chlorine with all 8. But now you got to go back in and add brackets indicating a charge or a change of electrons have occurred. Sodium is group 1, so it's +1. Chlorine is group 17, so it's -1. So let's go back and do this. We talked about these with valence electrons. Group 1 is always a +1. Group 2 is always a +2. Group 13 is always a +3. Those should be easy. 1, 2, 3. Now you get into group 14. It can either gain or lose 4. So it can be +4 or -4. Most of the time you're not going to be dealing with it. Group 15, it is easier for it to gain 3, so it's got a -3. Group 16, -2, you can see the theme going here. Group 17 is -1. Group 18 is 0, because they don't react. If you want to memorize that, go ahead, that's how I did it, or you can just kind of know what we did in the previous example. But you should write that in your notes somewhere. So 2, we have magnesium. Mg, group 2, it's got 2 dots. Oxygen, O, group 16, it's got 6 dots. All right. So now you're going to get magnesium to give up 1 to oxygen, and now oxygen has 7. So it's just turned into an Mg. with a 1 and oxygen with a 7. Our metal doesn't have all of them away yet. Our non-metal doesn't have 8, so obviously this is going to transfer over its other electron. So you're going to get, you're going to get Mg, once again with no dots, and your anion with all 8. Draw your brackets to indicate it's an ion. Now if you know your charges over here on the right, this is easy. If you don't, you have to go back through and count. Magnesium lost 2, so it's going to have a +2 charge. So, like you said, group 2, +2. Oxygen picked up 2, so it's got a -2 charge. So group 16, -2. It works every time. So magnesium and chlorine. I'm going to erase. Well, that's 2. And chlorine, group 17, well, that's 7. Oops, 7. So magnesium is going to give up 1, and now you have magnesium with 1 dot, and chlorine now has 8. You see a problem here. Magnesium still has 1, but chlorine already has 8. It can't take another one. So what happens here is another chlorine with its 7 is going to come in and pick up this extra electron. So you have magnesium with 0 dots now, and 2 chlorines that now have 8. So you can draw brackets around them, indicating that they are charged, they are ions. So magnesium gave up 2, so it's still +2, group 2 +2. Now each chlorine only picked up 1, so each charge is only going to be 1. That's why group 17, -1 charge. Now this is important because we've got to go back and make sure our charges are good. Has a +2 here, -1, -1 equals -2. So +2, -2, those charges do cancel. So you can draw it like that. Another way you're going to see it, especially when I draw these, is I'll draw my cation in the middle, and then I'll draw a chlorine on each side. Either way is fine. This makes more sense to me because this is actually more like how it looks. So either way you want to draw that is fine. So the only way you're going to get good at this is if you practice it. So I want you to go through the number 1 through 3, pause it, and then I'm going to go through and check your work. Number 3 is kind of difficult. 4, 5, and 6 you're going to do on your own. And if I don't see them done in class, you're not getting credit for doing the video. Alright, so calcium chloride. First off, you see you've got 2 chlorines here, so this should be a really big hint. So calcium is going to have no dots. It's the cation, it's the metal. It gave up 2. And each chlorine is going to have all 8 dots and a -1 charge. Okay. You could have also drawn the calcium between each chlorine. I'm just doing this for space really here. Potassium is your cation, it's your metal. So you draw it, no dots. Group 1 +1, gave up 1 electron. And bromine, group 17, started with 7, picked up the 1 from potassium. Group 17 -1. Now aluminum sulfide is kind of tricky. First off, you see you need 2 aluminums. So you can draw each of your aluminum, no dots, with its +3 charge each time. And then you can draw all your sulfurs. Now remember here, each sulfur ends up with 8, so it's going to have a -2 charge on all of these. Okay, and there's a bunch of different ways you could have drawn that. But as long as they're close together, I'm fine with that. So the next 3 are yours. You should probably check them off with me when you get back into class. And we'll move on to metallic bonding next.